Read it, please.
If the leg of a right triangle is 15, hypotenuse is 11. Find the missing length in the simplest radical form.
This is a right angle, correct? Opposite of right angle, this is a hypotenuse, correct? This is a leg, and this is a leg, because those are the two shorter ones, yes? So, the leg of our is 6, so one of them is 6. And the hypotenuse is 11. Find the missing leg in the simplest radical form. Remember, this is a squared plus b squared equals c squared, correct? A and b, these are legs, correct? C is the hypotenuse, which is opposite of the right angle, and it's also the longest side, correct? Let's set this up. This one's missing. I'm going to put X for that, okay? Do you see that? Six is a leg, so that's 6 squared plus X squared. These are the two shorter ones, yes? Equals the longest side, which is 11, correct? You know that's the longest one because it's the opposite of 90 degrees. So solve for X. Go. How do you get rid of the 36? I want you to turn that off now. Now. I'm not playing around with you, dude. 10, 4, 5. You still think it's a good idea for you to sit over there and look at your phone? We have no clue what the heck you're doing for tomorrow's test? You think I work that hard just so you can go on and fuck around and screw around like this? Your answer is already highlighted right here. Follow along and figure it out yourself. Or from the beginning.
The legs of the right triangle are 2x and 7x, and the hypotenuse is 12 and x.
Draw the picture. Okay, this is your right angle, right? Hypotenuse, leg, leg, correct? Then, if the legs of the right triangle are 2x and 7x, so the leg is 2x, this is 7x, because it's a longer leg, and the hypotenuse is 12. Find x, correct? Do you see where this is find x? You use the Pythagorean theorem, which is a squared plus b squared equals c squared, correct? Which one of these is going to be c squared? That's going to be c. This can be a. This can be b. But the a and b can be changed because they're both the legs, correct? So it doesn't matter which one's a and b. But the c matters. 12 squared, 7x squared, 2x squared, correct? 7x squared is going to be 7 times 7, which is 49x squared. 2x squared is 2x times 2x, which is 4x squared. Equals 144. Right? Combine your line terms. What's 49 plus 4? Now solve for x. In the square root, both sides, x equals the square root of 144 over the square root of 53. I know 144 is a 12, but then you have 53, correct? Can you have a square root on the bottom? No. How do you get rid of a square root on the bottom? You can always multiply by 1, correct? Which would be square root of 53 times square root of 53, correct? What happens here then? When you multiply this by this, what happens? It just becomes 53 without the square root, correct? On top, you get 12 square root 53. There's nothing you can do with the 53. That is going to be your answer. And you can't do anything with the 12 and the 53, so X is that. You do it yourself. Figure it out. All right, number 8. Go ahead.
ABC has verticals.
Vertices. That's point.
DEF has vertices.
1, 2, 3, 4, and then -4, 1, correct?
Yeah.
So that's A, -4, 1. And then B, -3, 1, 2, 3. Did you do this already? 1, 2, 3, 4. C, -1, 1. So then you have this triangle, right?
Yeah.
DEF has vertices 2, -3, 1, 2, 1, 2, 3. There's D. And then E, 5, 1, 2, 3, 4, 5, 1, 2. And F, 1, 2. That's F, correct?
Yeah.
So it's this triangle right here. What it's asking to do is prove or disprove. So it could be either agree or disagree, right? The triangles are congruent, right? So let's go ahead and take a look at the first part. First part is you have this triangle, right? You have this pink triangle, correct? And this one is A, B, C, correct? A is -4, 1. The reason I'm rewriting this is I can't see it on that grid. That grid's really hard to see. -3, 4. And C is -1, 1, correct? Yes? So we need to find the distance of the following. BC, right? AC, and AB, right? Okay. And then what we need to do, opposite of that, you have this triangle right here, which is D. D is 2, -3. E, which is 5, -2. And then F, which is 2, 0, right? So that means you need to find the distance of DE, right? EF, right? And then FD. And if they're exactly the same, then all three sides should match, right? Like 2 and 2, 4 and 4, 8 and 8, right? So go ahead and do that. And then I'll go over the answer with you when you're done. Okay, what did you do for BC? What's your answer for BC? The -3 plus 1 is a -2. 4 minus is a 3. So you have a 4 plus 9. So square root of 13, correct? Okay, next one. AC, what do you have? AC -4 plus 1. So it is 3. Okay, what do you have for AB? 1.
10.
So that's 1 plus 9, so square root of 10. So this is what you're starting off with, right? Now we want to do the same thing with the right side, and they're the same, then you should have square root of 13, 3, and 10. Square root of 10, right? Okay, what is DE?
It's 5.
I got square root of 10. DE, 2 minus 5 is -3. -3 plus 2 is -1. Do you see the mistake there? All right. EF is 2 is -3, 0. And then lastly, FD. FD. 2 minus 0, 2, 3. So that's going to be 3. Okay, so far everything matches. I can see that BC is equal to EF, which is square root of 13. I can see that AC is equal to FD, which is equal to 3. AB is equal to DE, which is square root of 10. So right there, triangles ABC is congruent to triangles DEF because all three sides are, because the three sides are congruent. So check to see what you did, okay? You see? Okay, good. Now you're gonna go on to number 9, and I'll go over it with you now. Prove or disprove that quadrilateral is a parallelogram. So in order for it to be a parallelogram, you know that the two sides have to be equal, correct? So I'm not even gonna draw this, I don't need to. So I have, well, I guess I can't. 1, 2, -2, 1, 2, 1, 2, 3. That's A, right? B is 1, 2, 3, 4, 5, 1, 2, 3. C is 1, 2, 3, -1. D is -3, 1, 2, 3, -1. Correct? So far, it kind of looks like it's a parallelogram, but we're not sure, right? So which distance do you need to find?
AB, BC,
Okay. AB. What else?
BC,
Okay. What else?
CD,
What else?
AD.
I think it's expected that probably AD and BC are the same, right? AB and BC, right? Or AD. Hold on. AD and BC, AD and BC, right? They should be the same, correct? And then it's also expected that BC and DC should be the same, right? Okay, so let's go ahead and do that. So AB, correct? -2 minus 5 is a -7 squared. 3 minus 3 is 0, correct? 49, which is just 7, right? Now let's take a look at CD. CD. 3 minus -3 is a 9, correct? -1 plus 1 is a 0. So that is also, well, actually, that's going to give you a 9, correct? Do you see that? So far it's not equal, right? But that's okay. Let's keep trying. BC. B and C, correct? 5 minus 3 is a 2 squared. 3 plus 1 is going to give you a 4 squared, right? So that's 4 plus 16, square root of 20, which is 5 times 4, so 2 square root of 5, correct? Okay. Now let's take a look at AD. So AD. -2 plus 3 is a 1 squared. 3 plus 1 is a 4 squared, which is 1 plus 16, so that's square root of 17. Do you see that? So far, does it seem like they are the same? No. So you can say ABCD is not a parallelogram because why?
Because none of the sides are the same.
Yeah, AB is not equal to CD, right? And BC is not equal to AD. So yeah, that's it, right? All right, I'm gonna give you a chance to work on 10. I'll come back and help. Okay, read number 10.
Suppose you would prove that the midpoint of a hypotenuse of a right triangle is the same distance from each of its vertices. Draw the right triangle on a coordinate grid so that it represents all the right triangles. Be strategic on where you locate the triangle. Complete the proof.
Midpoint of the hypotenuse of a right triangle is the same distance from each of the 3 vertices, right? So just to draw this is a right triangle, right? This is a hypotenuse, right? Midpoint of the hypotenuse is right here, correct? There has to be a point here and a point here is the same distance from each of the three vertices. The three vertices are this point here, and this point here. So what it's saying is that what can this midpoint be, correct? So that this point to this point is the same thing as this point to this point is the same thing as this point to this point. Do you see that? Do you see that? So the orange is going to be the same thing as the yellow. The vertices of the three blue points, right? Yeah. Is the same thing as the pink. Do you see that? It's a right triangle, so the only one I know is 6, 8, and 10, correct? This is a really hard question. I don't even know how the hell you're gonna answer this question. Let's see what AI is gonna say. No, he has not. But we also know that he's not very good at planning, so he said that he was gonna be behind, right? Well, I don't know. Like, figure something out. Like, if you didn't know how to do the answer, how would you go ahead and go about trying to figure out the answer? Write something new. At least label it.